Okay, so let's have a timeless piece of material.
Okay,
You
postulate
can
that.
imagine that. You can imagine that, right?
I don't think so because, again, time just does follow upon matter. That is what time is. Time is the
Can't
measure.
you have can't you have matter at 0 degrees Kelvin? I took chemistry. At 0 degree Kelvin, you have no motion, but you still have
Okay,
matter.
okay. I have no idea what 0 degrees Kelvin is or any of that, but okay.
Okay.
So you'll see here a bit of a cessation on my part, and I don't try to hide that. He did actually object to the argument, and it wasn't something that I was familiar with. Just prior to this, I had tried to move on to a different question. I had a lot of questions outlined that I wanted to get to. But he came back with this, and it did catch me off guard. I don't try to hide that. However, it is far from a defeater of the Kalam, or the problem of the infinite number of past events, and here are some problems that I have come up with in retrospect of this. The first one is that the claim is false. 0 degrees Kelvin does not produce, quote unquote, no motion. That's just not the case. And here's some quotes from some physicists on the matter. Quote, but matter cannot reach absolute zero because of the quantum nature of particles. This has to do with Heisenberg's uncertainty principle. In parentheses, we can never know exactly both a particle's speed and position. In fact, the more precisely we know its speed, the less precisely we know its position. A second quote, there really is no physical description that allows for an atom at zero temperature. This is physicist Eric Ramberg of Fermilab. If an atom could attain absolute zero, its wave function would extend across the universe, which means the atom is located nowhere. But that's an impossibility. So here's some physicists saying that this is actually impossible, and I'll leave a link in the description if you want to fact check me on that. So this was nothing more than a play on my ignorance of chemistry, which shouldn't have been hard to deduce, and a closer look proved the statement false, according to physicists who presumably have a superior knowledge of Doug and myself. Second, we also know that the initial condition of the Big Bang was extremely hot and that the universe is now cooled off. And Doug is postulating an initial condition of 0 degrees Kelvin, the coldest possible temperature where there is no motion. How does something at 0 degrees Kelvin get to something extremely hot if there's no motion? It simply does not. It's impossible. But even still, let us assume that there was once a single material thing in the entire universe. That's all that exists, and it's existing at 0 degrees Kelvin, and there's absolutely no motion, zero motion. There's no other particles, there's no nothing, just this one little material thing at 0 degrees Kelvin with no motion. Let's imagine that for just a second. Now, reminder, this is actually impossible according to physicists. But how do you get from that state to where we are today? How would you get here? You have to have something actualize the potential of that single material thing to become the universe that you and I now live in. How does that happen? In the absence of any motion, you could never get here. You couldn't go anywhere. You have to have something else to actualize it. If this material thing actualized its own potential to get here, that would mean that some part of it would be in motion. But then there would be time, and that would defeat the purpose of hypothesizing such an impossible state. If there was a time when there was a single material motionless thing, that is all there ever would have been.